There's a small bump on your laptop charger that most people ignore, yet it's doing something surprisingly important every time you plug it in. It looks ordinary, but it plays a role most people never notice daily. It doesn't glow or click or give any obvious sign it's working, but without it, your devices wouldn't behave quite the same way. So what exactly is that strange little cylinder, and why is it there on so many cables? Today we're answering that simple question that hides a deeper story about how modern electronics stay stable and reliable. Stick around as we uncover what it really does right here on History of Simple Things. That plastic cylinder on your laptop charger isn't just plastic. It's actually housing a component called a ferrite bead, sometimes also known as a ferrite core or ferrite choke. Inside that casing is a ring made from ferrite, a magnetic ceramic material typically composed of iron oxide. The cable itself passes through this core, which is why it looks like a thickened section of the wire rather than a separate attachment. This design is intentional and has been used in electronics for decades. You'll often find similar cylinders on other cables too, like monitor cords, printer cables, and even some USB wires. Despite how common it is, the ferrite bead remains one of those components people rarely think about, mainly because it works silently in the background without any visible effect. To understand why the ferrite bead exists, you first have to understand a hidden issue in electronics: electromagnetic interference, or EMI. Whenever electricity flows through a wire, especially in modern devices that rapidly switch power on and off, it can create high-frequency electrical noise. This noise doesn't just stay in the wire, it can radiate outward like a tiny antenna. At the same time, cables can also pick up interference from the environment, including signals from Wi-Fi routers, radios, and other electronics. This creates a messy situation where signals overlap, interfere, and potentially disrupt how devices function. Without some form of control, this interference could cause anything from minor glitches to noticeable performance issues. The ferrite bead acts as a filter that specifically targets high-frequency noise while allowing normal electrical current to pass through. It works by using the magnetic properties of ferrite material to resist rapid changes in current, which are characteristic of unwanted noise. When these high-frequency signals try to pass through the cable, the ferrite core absorbs and dissipates them, often converting that energy into a small amount of heat. Meanwhile, the lower frequency power that your laptop actually needs flows through without much resistance. This selective filtering is what makes the ferrite bead so effective. It doesn't interfere with charging, but it cleans up the signal traveling along the cable. You might notice that the cylinder is usually located near the end of the cable, often closer to the laptop itself. That placement isn't random. Engineers position the ferrite bead where it can best block interference either entering or leaving the device. Since the cable can act like an antenna, placing the ferrite core near the device helps prevent unwanted signals from reaching sensitive internal components. It also stops the cable from broadcasting noise outward into nearby electronics. This dual role, blocking incoming interference and suppressing outgoing noise, is what makes the ferrite bead so effective in maintaining stable performance across devices. Without a ferrite bead, most laptop chargers would still work, but they wouldn't work as cleanly. The cable could emit more electromagnetic noise, potentially interfering with nearby devices like speakers, monitors, or radios. In some cases, you might hear faint buzzing sounds in audio equipment or notice flickering on screens. At the same time, the laptop itself could become more vulnerable to interference coming from other devices, which might lead to unstable power delivery or minor glitches. While these issues aren't always dramatic, they can add up, especially in environments filled with electronic signals. The ferrite bead acts as a safeguard, reducing these risks and improving overall reliability. Interestingly, newer chargers don't always have that visible cylinder, and that's because technology has improved. Modern cables often include better shielding built directly into the wire, which reduces the need for an external ferrite bead. In some cases, the filtering components are integrated inside the charger brick itself instead of being placed along the cable. However, ferrite beads haven't disappeared entirely. They're still used in situations where interference is more likely or where stable performance is critical, such as in medical equipment or high-quality audio and video systems. So even if you don't always see that cylinder anymore, the function it serves is still very much a part of modern electronics. That small plastic cylinder on your laptop charger is easy to overlook, but it represents a thoughtful piece of engineering designed to handle a problem most people never even notice. It quietly filters out electrical noise, keeps signals clean, and helps devices coexist without interfering with one another. It's a reminder that not every important feature is flashy or obvious. Sometimes the most crucial components are the ones doing their job in complete silence. And once you know what it does, it's hard not to see that little bump as something far more intentional than it first appears. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.